of Indonesia and South America, but for the fact that the dynamics of the planet, and this ultimately is, if we're looking for a cause, or some people would say a villain, then it's the climatological dynamics of the planet which began to limit these rainforest habitats. And a new kind of habitat began to form in Africa, which was grassland. It's very recent. And under nutritional pressure, and under a pressure that was the result of this retreating environment, our remote ancestors descended from the trees and began to adapt themselves to the new world of the grassland. And they did this over a period of probably a couple of million years. Now, I maintain, and if any of you are evolutionary biologists or anthropologists, this is the nub of my position. Here's what's new scientifically. What they teach you about evolution is that it's caused by mutation, which is a random process, which then meets another random process, which is natural selection. And out of these two random processes, lo and behold, you get sea urchins, birds of paradise, gray whales, and human beings. Now, when you inquire as to what is the source of this mutation, you will be told it's cosmic rays, incident incoming hard radiation which can disrupt chromosomes, and then most of these mutations are lethal, some huge percentage of them, but a vanishingly small number of them actually confer adaptive advantage, and they are then preserved in the genome and passed on. Now, what I want to suggest, and I've never seen it thoroughly treated by evolutionary thinkers, is that food is the unexamined source of evolutionary pressure. It can be. If you know anything about animal species, you know that most animals tend to specialize their diet. Insects are famous for this. If you find a caterpillar and you want to raise it in a jar, you must give it the food plant you found it on, because they don't just eat leaves. It doesn't work like that. They have species-specific adaptations. Now, why is this? It's because it's a strategy to limit exposure to toxic and mutagenic chemicals that other life forms are sequestering in their tissue to discourage predation, essentially. Well, so then what happens when an animal population, such as our remote ancestors, comes under pressure from a dwindling habitat or a limited availability of food? Well, what happens, if you have any sense, is you start experimenting. You start digging up roots you never thought about before and chewing on them. You start eating leaves. You start eating insect protein. You experiment with the slaughter of small animals and so forth and so on. And this is precisely what our remote ancestors did. This is the much lamented transition from fruitarian holiness to predatory carnivorous messiness. But had we not been willing to lower our gourmet standards, we would have entered the fossil record at that point. So here we have these proto-hominids foraging into this new grassland environment, beginning to beat on prairie dogs and stuff like that, and simultaneously, as we all know, evolving in this African veldt environment were great herds of ungulate animals, proto-cattle, bison, wildebeest, antelopes, many, many different kinds of animals. And one of the curiosities of nature is that many mushrooms prefer the dung of ungulate animals to just going out and making a deal with the raw natural environment. They like the leavening that goes on with vegetable material when it passes through the double stomach of an ungulate animal. As a headline, what this means is mushrooms grow in manure. And so our remote ancestors, testing for insects and eating small animals, would certainly have encountered the so-called coprophytic or coprophilic, the dung-loving mushrooms. And they would have tested them for food. Years ago when I was in Kenya, I observed baboon troops in this very environment we're discussing, and their habit was they were very interested in cow pies because they had learned from experience that if you rush over to a relatively old cow pie and flip it over, there's a high probability of beetles or beetle grubs under there, and so these were vectors for food getting. Well, I did not observe mushrooms in Africa, but I observed mushrooms in the Amazon, and they can attain the size of a dinner plate. I've never seen them in cultivation quite that large. But, you know, you come out after a hard rain, and these things are landed like little flying saucers or frisbees in the meadows. They would certainly have been tested for their nutritional potential. And psilocybin, different from all other chemicals in nature, including, as far as I can tell, all other hallucinogenic chemicals in nature, psilocybin has a unique set of characteristics which implicate it, to my mind, very strongly in the catalyzing of the emergence of humanness out of proto-hominid and hominid organization. And it works like this. It's very relatively easy to understand as major scientific breakthroughs go. At least you're not going to be asked to do any partial differential equations this evening. Psilocybin in very low doses, doses so low that if you were to take a dose this low, you could conceivably forget you had done it and just go out and shop and fiddle around. But at doses so low that they do not register as a psychedelic experience, psilocybin imparts measurable improvement in visual acuity. Roland Fisher did this work in the late 50s and early 60s, and they built an experimental device where a person who could not be seen, by turning a crank, there were two parallel bars. And by turning a crank, this person could rotate one of the parallel bars so that it was no longer parallel. And lacking talking rats, they went to the next preferred experimental animal, which is graduate students. And they would sit a graduate student down in front of this device, give them a very low dose of psilocybin, and then put a buzzer in their hand and say, when the two bars are no longer parallel, push the buzzer. And Fisher collected large amounts of data which showed that the people who had taken the psilocybin, and the other people were given placebo, of course, could detect this deformation long before the unstoned subjects were able to do so. And Fisher, who was a totally straight European scientist, in fact a Viennese, when I talked to him about this stuff, he was very cagey, and he was funny. In fact, he said, well, you see, it's very interesting. Apparently here we have data which argues significantly that we are perceiving reality better with the drug than without the drug. Yes, yes. For him, that was a joke. I mean, he never did anything with it. It was just a throwaway line. But it stuck with me. And I don't think you have to be a rocket scientist to see that if you are a hunting animal in a situation of nutritional pressure, as our remote ancestors were, and there is a